All right, let's finish up this example that we were working on. So the derivative of tangent theta is secant squared theta times d theta dt equals 1 over 2,000 times then the derivative dt. Well, we could start plugging in stuff, but we don't know ds dt. So we can find that by taking the derivative of this function here. So 2 times t to the first, and then times, what's dt? The derivative of matches the variable that you're taking the derivative with respect to. That's just 1. That's just not even necessary. So the derivative of ds dt is 100t. All right, so that's what we're going to plug in there. After you take the derivative is when you start plugging things in. D theta dt is what we're trying to find. What's our angle of elevation? We're going to call that theta still. We're going to leave that as theta. So far we've got secant squared theta times d theta dt equals 1 over 2,000 ds dt. We're going to put 100 in there. We're also going to divide by secant squared. So we can get d theta dt by equals 1 over 2,000 times 100. Multiplying by secant squared is the same as multiplying by the reciprocal. Um, 100 divided by 2,000. And then times the reciprocal, so 1 over secant squared. But remember what secant is. Secant squared theta based on this, because we know that our time is 10 seconds. So when time is 10 seconds, 10 squared is 100 times 50. So 50 times 100 is 5,000. The height of this rocket ship at 10 seconds is 5,000 feet. So if we know that's 5,000, and this is a constant 2,000, so at the point after 10 seconds after liftoff, we can find the angle here. This angle would be tangent opposite over adjacent. So we can find that angle, do the inverse tangent of 5 over 2, because those thousands can cancel. Make sure you're in radians. 1.19 approximately. And then we want to do cosine. Remember when you're rounding, to round to at least 0.19, I gotta rewrite that, 1.19028, so 1.1903. And then do cosine of that angle, and we're gonna plug in a 10 here. So we have 10 over 20, so it's 1/2, times cosine of 3, and then that's going to be squared. So it's about 0.069. Always leave your answer in terms of 3 decimal places. All right, and units on that would be radians per second, because our angle is in radians and it's with respect to time, angle with respect to time. So the angle is radians and this time, so radians per second. And finally, your homework is page 154, 1 through 21 odd.